Okay, in this video we're going to be looking at some more linear modeling, and we're going to start off by looking at the equation of a line written in slope-intercept form, y equals mx plus b, where m is your slope and b is the y-intercept. And recall that the y-intercept is where your line crosses the y-axis. Be sure you know what a positive slope looks like and what a negative slope looks like. These kind of help you double check your work and be sure that you're getting your graph right. Okay, we're going to start off by looking at subequations and identifying the slope and the y-intercept. Remember that the slope-intercept form is y equals mx plus b. So I can see here that on problem 1, the m is 2 and the y-intercept is 1. On problem 2, the slope is 1/2. And the y-intercept is -2. Be sure that you get that negative sign in there with it. Now, problem 3 doesn't look like it's exactly in slope-intercept form because I don't have a number that's added out here. Slope's easy to identify. It's 2. But what about the y-intercept? Well, I can add a 0 and not change the value of this equation. So my y-intercept is 0. And on problem 4, I don't have a number in front of the x, but I can easily put a 1 there because 1 times x is the same thing as x. So my slope is 1, the y-intercept is -4. Problem 5 is just here to show you that a slope can be negative. And on problem 6, this is not in slope-intercept form, right? I need the x term first. So I'm going to have to switch this around to where it's y equals -4x plus 20. And then I can say that my slope is -4 and the y-intercept is +20. Problem 7. A $1,000 computer depreciates at a rate of $100 per year. Depreciates means that the value is going down. Write an equation to model the situation where x is the number of years and y is the value of the computer. I think in this problem, it makes sense to start my equation off with the 1,000, right? Because that's the initial value of the computer. And then the value is going down $100 every year. So even though this is not exactly in slope-intercept form, I think this is the way that makes the most sense to write the equation. Now, if you wanted to switch that around and write it as -100x plus 1,000, that's fine. The number of years is the independent variable, and the value of the laptop is the dependent variable. Okay. The value of the laptop depends on how old it is. All right, the next part here is to graph the equation. And there's a couple of different ways that I can go about doing this. I can make a table of values and plot it, or I can plot this by using slope is rise over run. I know that the initial value of the computer is 1,000. And as I go along the x-axis, every year I move over, the value of the computer is going to go down $100. I go over 1 year and I'm going to be going down $100. So I can continue this graph on until I get to here. Right? So in 10 years, the value of the computer will be 0. So I want to connect these dots. So I connect the dots, and that's what my graph looks like. The last part of this problem asks us to determine the value of the laptop after 3 years. There's a couple of different ways that I can figure out the answer to this. One way is by using my graph. Let's look at this value right here. After 3 years, I can go up to my graph and then go over to the left. I see that the value is $700. The other way to do this problem is to go back to my equation, y equals 1,000 minus 100x, and I know that x is going to be 3 because 3 is the number of years. So I put 3 in for x, and that's going to give me 700 as well. Okay, problem number 8. The cost of publishing a poster is $2,000 for setting up the printing equipment, plus $5 per poster printed. What is the dependent variable? The dependent variable is the cost, and the independent variable is the number of posters printed. And the equation is going to be $2,000 for the initial setup plus $5 per poster. And what is the total cost to produce 2,000 posters? It's going to be found by taking this equation and putting 2,000 in place of that x. So I'm going to get the cost to be $12,000. Okay, now the next thing I need to do is to graph the equation. Okay, let's start off by graphing this by plotting my y-intercept, which is going to be 2,000. Now, the previous problem, I was going like over 1 year and down 100. But notice if I go over one poster, I'm only going to be going down $5. And I cannot really get that on this graph because my graph is going by 400s on the x-axis and it's going by 2,000s on the y-axis. So what I want to do is to get another point on here that's kind of far away. I want my x value to be 400, 800, even 1,600 or 2,000 because we just figured out what this point up here is. We know that the point 2,000, 12,000 is on the graph. So if I go over 2,000 and then up to 12,000, I will get to this point. And then I can connect those 2 points. And that's the graph of my equation.